what are the data types in Python. So coming to these data types in this Python, we're having some list of data types: integer, float, boolean, complex, string. So these are the first 5 fundamental data types in the Python. And also we are having some more data types like list, tuple, set, frozen set, range, dictionary, bytes, byte array, none. So these are all the list of data types that we're having in the Python. In these first 5 are the fundamental data types in the Python. So these data types that we can call, okay, fundamental data types in Python, or also we can call these are the standard data types in the Python. And the remaining data types, okay, these we can call these are the advanced data types in the Python. So first let us observe this. What are the fundamental data types in the Python? So integer. So we can use integer data type to represent the whole number that is in the integral values, like a equals to 10, 20, minus 200, minus 500. So these type of values that we can consider as an integer. And also we observe that integer is belongs to immutable data type. So here it is not possible to change the value in the existing location. So integer is the immutable data type, and also we don't have a multiple types of integers like long int, short int, okay, signed or unsigned int, so and so, like other programming languages. We're having only one data type, that is the integer data type. So this integer data type that we can represent in different ways. So let us observe the first integer in depth. Int means integer values. So like 10, 20, minus 300, minus 500. So these type of values that we can consider as integral values. So these integral values that we can represent in the following ways. So let us observe this. These integer values that we can represent in the form of decimal form. We can represent in the form of binary form. We can represent in the form of octal form. We can represent in the form of hexadecimal form. So that we can represent these decimal values in these different forms. So let us observe one by one. What is this decimal form? So the normal integral values, the whole integral values, so these values that we can consider as the decimal form. So what is the base value for this decimal form means? Okay, the base value it is 10. The base value is 10. So what are the digits it contains means? It contains from 0 to 9. The digits from 0 to 9 is comes under the digital form. By default, the number it is going to take as a decimal only. For example, 10, 20, 30. So these values that we can consider as decimal form. Next, coming to the base form, binary form. What is the base for this binary means? Binary in the name itself, okay, binary, either this or that. That is 0, base is 2, and the values it allows 0 and 1. And the values it allows 0 and 1. Coming to the octal. So what is the base for the octal? It is 8. So it allows the digits from 0 to 7. 0 to 7. Next, coming to the hexadecimal. Hexadecimal. The base is 16. The values it allows from 0 to 9. 0 to 9. And also it allows the characters A to F. So this A to F that you can take capital A to F or small a to F. It allows both lowercase and uppercase. Let us observe here. Here I am going to take some values. I want to take the binary value. So I want to take a 15. What is the binary value for the 15? 1111. 1111. So now let us observe here. I am taking A equals to 1111. Now, if I print this A, what is the value it will return? What is the value it will return? My requirement is that I want to take the binary value, that is 1111 is equals to the 15. So now if I take this 1111, how it is going to consider? Yes, please type in the chart. It will consider as a decimal form only. Why? Because by default, the Python will take in the form of decimal. 1111 it will consider as a 1111, not in the binary form. So if you want to represent the data in the form of a binary form, or if you want to represent in the form of a octal form or hexadecimal form, at the time we are having some prefixes. Based on the prefix that we have to define the binary, octal or hexadecimal. Otherwise, by default, it is going to consider as a decimal form. Right? So, for literal values should be prefixed with. For binary, we are having some prefix. For octal, for hexadecimal, that we are having some prefixes. So, for decimal, there is no prefix. Why? Because by default, the whole number it is going to take as in the form of decimal form only. So whenever if you want to represent in the form of binary, at the time that we have to give the prefix 0B or 0 caps B. So if you want to represent in the form of octal, so then we have to give the prefix with octal means O. 0 O or 0 caps O. Don't confuse. First it is 0, next it is O. Next, coming to the hexadecimal, 0x or 0 caps X, right? So they same 1111 I want to represent in the form of binary. Before that, we have to give the prefix 0b. Then only it will consider. Python will understand that it is in the form of binary. So the values it will read only 0 and 1 with the base 2. So let us observe here. A equals to 0B 1111. Now it is in the form of binary. Now it is in the form of binary. Okay, Python read this value in the form of binary. So what is the value for this binary 1111 means? It is equals to 15. So now it is going to represent print in the form of, okay, decimal. It is reading as binary only. Whenever you are printing, okay, it will print in the form of decimal form. By default, it is going to work as a decimal form only. Even if you want to print, it will return in the binary, that is decimal form only with the base 10. So like this, that we have to, okay, represents the binary values, octal values, hexadecimal values. So let us observe here. I'm taking some of the values. A equals to 0, octal means O. 0, O, 1, 2, 3. No problem. It will accept. If I print, it returns in the form of decimal. A equals to 0x, okay, 1, 2, 3, 4, hexadecimal form. Hexadecimal form. It is going to print in the form of this. Now A equals to 0x. I'm taking face. So please open the chart and then reply for this. Now this value will accept as a hexadecimal or not. Yes, please. Yes, it will accept. Why? Because FACE. These are the digits, values comes under the hexadecimal. So it allows the digits from 0 to 9 and A to F, whether it is a small case or uppercase. No problem. A equals to 0x, I'm taking B. Now, it will accept or not? No. Why? R is not a valid digit in the hexadecimal, so it will not accept. A equals to 0B, I'm taking in the form of binary, 0, 1, 0, 1, 2. Will accept? No. No, it will not accept. Why? Because 2 is not a valid value under binary. So here we have to take a valid digits comes under the binary, octal, hexadecimal. So then only it will accept. But maximum that we are going to work with the natural values, that is in the form of decimal. Very rare we are going to use these binary values, octal values, hexadecimal values and all. But anyhow, it is better to know that what are the prefixes that we are having, what are the ranges, what is the base values and all. By default, it is returning, it is printing in the decimal form only. Otherwise, if you want to return in a specific base format, or if you want to do the conversion from one base to another base, are you getting? If you want to return in the binary format, or if you want to return in the octal or hexadecimal, otherwise if you want to convert from one base to another base, like for example, binary is there, that value that I want to convert into octal, octal is there, that I want to know the base conversion concept. So in these base conversions, we are having some of the inbuilt functions. So Python is providing some of the inbuilt functions for the base conversions. So what are those means? Okay, first it is binary function. So this binary function is used to convert from any base to binary. Next, octal function, OCT. So this octal function is used to convert from any base to octal. Next, hexadecimal. This hexadecimal inbuilt function is used to convert from any base to hexadecimal, right? So let us start working here. Actually, 15, for example, let us take 15. So 15, what is this 15? 15 is a integer value. So all are integer values only, but it is in the form of decimal. So this decimal form value that I want to convert into binary. So actually, if you want to read this 15 in the form of binary, that will give the prefix 0b, and then we will take in the in the form of binary, that is 1111. But even if you are taking the value in the form of binary, at the time of printing, it will print it in the form of decimal only. Why? Because the default form in the Python, it is decimal. So now, if you want to convert the base of this 15, so then we are going to use the inbuilt function bin. Now it is going to return in the form of binary. See, bin of 0x10. 0x10 is the hexadecimal value. This I am converting into the binary. Let us check it. Bin of 0O10. So this is the octal value. This I am converting into the form of binary. So like this, by using this inbuilt function that we can convert from one base to another base. Don't confuse. It is not type conversion. We are not converting from one data type to another data type. We are working on only one data type, that is integer data type. Integer is again having some different forms. Just we are converting from one form to another form. That is, just we are converting from one base to another base in the integer data type only. So that is the reason, okay, we are calling it is a base conversion, not an type conversion. Type conversion means converting from one data type to another data type, like integer to float, float to some other data type. So that it is comes under data type conversion. But now we are discussing about only the base conversion which belongs to the integer data type, right? So let us observe the octal. So 15 is the decimal value. So now I am converting into octal. So like this, that you can convert any other base to octal here, octal form. 0B1111, it is the binary converting into octal. 0x123, it is the hexadecimal converting into octal. Hexadecimal value 0B1111, binary to hexadecimal, decimal to hexadecimal, octal to hexadecimal. So like this, that we can do the base conversions from one base to another base, right? So this is about integer data type. Mostly we are going to work with that is decimal forms in the integer only. But anyhow, that we have to know what are the different forms, how to work with it, what are the prefix that we are having, what are the bases, what are the base conversion inbuilt function and all this. So next, float data type. Float data type. What are the floating point values? Floating point values like 10.5, 200 minus 0.25, minus 30.3, minus 600 point. So these type of values that we can take under float. Under float. So let us observe here. A equals to 10.5. If you print it, return the value 10.5. If you observe what is the internal data type of this, it is a float. So no need to specify from our side, it is a float or it is an int. Why? Because Python is a dynamic type of programming language. So no need to declare. By default, Python is going to take it. So we can also represent the float point values by using the exponential form, like scientific notation. So these type of values that we can observe, okay, whenever the value is not fitted on the screen, if it is having lengthy in calculators, in Excel sheets, we can observe some exponent value like 1.2E3 like this. So what is the meaning of this means? What is the meaning of this 1.2E3 means? Okay, that is 10 power 3. So if the value is not fitting at the time, it is going to represent like this. So these type of values also it will represent. Okay, no problem. Let us check it. So the value it is 1200. So instead of small e, we can use the cap C also. So the main advantage of exponential form is we can represent the big values in less memory. See, we can represent the integer values in decimal, binary, octal, and hexadecimal forms, but we represent float values only by using a decimal form. Only by using a decimal form, like that is with the base 10, the digits from 0 to 9. But if you try to take in the form of binary, octal, or hexadecimal, so it will not accept. So it is better to observe 0B1111.11. So if I am trying to take this float value in the form of binary, it will not accept. So it will not accept the octal or hexadecimal also. So it will accept only in the form of decimal form. Only in the form of decimal form. Now, the question here it is, this float is belongs to mutable data type or immutable data type. So let us observe here. I'm taking a equals to 10.5. So I'm returning. Let us check the type of this. Let us check the ID of this 10.5. So now I'm trying to update the value of this a. So that is a equals to 20.5. So here, okay, now a is holding the value. It is 20.5. Even if you check this type, it is belongs to integer float only. If I check the ID, right, already that we know the concept that what is immutable and what is immutable. The value is updated in the same location, that is in the same address, that is in the same ID, then it is comes under the mutable. Otherwise, the value is created in the different ID, then it is comes under immutable data type. So already we observe that integer is an immutable data type. There the value is not updating on the existing variable. So here also, okay, the value is not updating. See, the IDs are different. So float is also immutable data type. So like this that you have to know each and every data type, whether it is belongs to the mutable or immutable, right? So here float is the immutable data type, right? So next, boolean. So boolean values, okay, that we can represent this type of data type that you can represent for the boolean values. So here it will allows only the two, that is true or false. Only two values, true and false. So internally, Python represents this true as 1, true as 1, false as 0. So these values also that we have to take as per our reserved keywords only. True means if you try to take the true like this, true, it will not accept. If you try to take the true like this, it will not accept. If you try to take the true like this, okay, it will not accept. So here we have to take the true as per the reserved keyword. The reserved keyword, it is true like this. First T is caps, remaining all are small. Similarly, the false also, okay. So if you try to take like this, it will not represent. If you try to take like this, it will not represent. False means, okay, we have to take like this only. False values that we have to take as per the reserved keyword. What are the reserved keywords that you are having for the true and false means? So these are the reserved keywords as per this only, as per reserved keywords only we have to take it. Otherwise, Python will not accept. So let us observe here. I'm going to work with the Boolean values. A equals to true I am taking. So Python will not consider this true. You'll get an error. A equals to true, it will not consider. A equals to true as per the reserved keyword only that we have to take this. So now it is accepting. Let us print this. It is a true. Let us check the type of this A. It is Boolean. Let us check the ID of this A. It is having some address. Now I'm taking that A equals to false. So if you print it returns false. If you check the type, it is belongs to Boolean data type. If you check the ID, here also it is having different address. So Boolean is also belongs to the immutable data type. Boolean is also belongs to the immutable data type. Where we'll use this Boolean means at the time of working with the conditionals, at the time of working with the logicals, decisions. So there we are going to return the output, either it is the result is belongs, okay, is a true or false. See, let us observe here. I'm taking that A value, B value. So A is 10, B is 20. Now I'm comparing that A is greater than, A is less than B. So if A is less than B, it returns that it is true. Otherwise, A is greater than B, it returns the condition it is false. So in these cases that we are going to use this, Boolean values. And we know that internally it is represents with true means 1, false means 0. So if I do like this, internally it is having a value for this true and value for this false. So based on that you will get the output 1 true plus true. It is 1 plus 1. True minus false. It is 1 minus 0, 1. So like this, okay, it will work. Right. So next, complex data type. Complex data type. See, complex is not a new data type for us. Why? Because this is one of the data type. These type of values already that we learn in our mathematics. That is in the school level. Okay, in the schooling in mathematics that we are having these complex values. But if you observe other programming languages like C, C++, Java, C Sharp, and so, those programming languages will not support the complex data type. They'll not accept the concept complex data type. They don't have any data type to represent the complex values. But complex values are very important, and these values are not new, right? Python will allows these complex values with the data type that is complex data type. So let us observe here. A complex is in the form of, actually we learn the complex values. So can you please type in the chart some examples complex values like 2 plus 3 I, 10 plus 20 I. So like this that you are having the complex values. So this is the format. So why this I means, actually I mathematics, why we are using I there means I is the imaginary value. So imaginary, so that is the reason we are taking that it is I. But here Python will not accept this I. This Guido van Rossum created one syntax for the complex. Actually, it is A plus B. A plus bi is the format that we learned in the mathematics. Why we took the I there means I means it is an imaginary. It is easy to understand that it is the imaginary value in the complex data type. But Guido van Rossum created that it is A plus bj. The syntax, the form he created, it is A plus bj. So there is no other reasons why he created and so and so. So we have to follow as it is only. So there is no option. Instead of J, if you try to take any other character, Python will not accept. Why? Because the syntax that they framed with the character that is J. So we have to take the data type as J only. So here the format, it is A plus bj. A and B contains integer values or float point values. That is your wish. That is your wish. So let us observe some of the examples here. So now I'm taking the A is 2 plus 3 I. I is okay. It is up to mathematics. In the written, it is okay. But if you use this I in the Python, it will not accept. So it is mandatory that we have to take A plus 2 plus 3J. That is A plus BJ. So let us print this A. Check the type of this A. So it is a complex that you can take in the positive and negative your wish. A equals to 10 plus 5.5j. It will accept 0.5 plus 0.1j. Okay, it will accept. So what is this A and B here means? A is the real value. A is the real value. This is the real part. We can consider it is a real value. Bj is the imaginary part. We can call it as an imaginary value. Right? So in the real part, if we use into value, then we can specify that either by decimal, octal, binary or hexadecimal. So this this real value that we can take in the form of decimal, binary, octal, or hexadecimal. Why? Because integer is having different forms, but float is not going to accept all this. It will accept only the decimal form, right? But imaginary part should be specified with the decimal. See, let us observe with the examples that we can understand more clearly. A equals to, I'm taking this real value 0b 1111, so that we know that these float values will not accept this binary, octal, hexadecimal. So integer only it will accept. So real value is this, and I am taking 10j. 10j. Okay, no problem. Next, 0b1111 plus 0b1111j I am taking. So let us observe here. Imaginary part should be specified only by using a decimal form. Other than that, if you try to take the imaginary value, it will not accept. It will not accept. So these 2 points that we have to remember. In the real part, if we use int value, then we can specify that either by decimal, octal, binary, or hexadecimal. But imaginary part should be specified only by using a decimal form only. So like this, that we have to work with this complex 10 plus 20j. So whenever if I'm printing, here it is returning the entire complex value. Means here it is returning 10 plus 20j. Here it is returning the real value, and also it is returning the imaginary value. So whenever if you want to return a specific part in this complex, like I want to return only the imaginary value, I want to return only the real value. So at the time, this complex data types contain some inbuilt attributes to retrieve the real part and imaginary part. So what are those attributes? Means real is the value attribute to return the real value. Imag is the attribute to return the imaginary value. So at present the data is available. 10 plus 20j is available in the variable a, right? So a dot real, like this, that we have to return the real value, a dot imaginary. So like this, that we can return the imaginary value, right? See, actually, I taken this 10 as an integer, 20 is also integer. But at the time of returning, it is returning in the form of float. Why? Because by default, complex will take in the form of complex data stored in the form of float value. If you give 10, internally it is going to take as 10.0. If you give 20, say this 20 is going to consider as a 20.0. By default, it is going to take these values with the float data type. So that is the reason it is returning with the float values only. So we can use this complex type generally in scientific applications and electrical engineering applications. Next, last fundamental data type in the Python, that is string data type. So string str represents the string data type. A string is a sequence of characters enclosed with a single quote or double quote. See, A equals to, I'm taking Srinivas Reddy. If you not enclose this Srinivas Reddy in a single quote or double quote, it is not comes under a string. It is not comes under a string. String always that we have to enclose with a quotes, either it is a single quote or double quote, then only it is considered as a string. So now let us take this entire string in a double quote or a single quote. Python programming. And one more thing. open, okay, enclosed with the same quotes only. So here, if, okay, I use the double quote, right? Ending also we have to use the double quote only. It's not, okay, uh, considered with the different quotes, like starting with the double, ending with single, it will not consider. So with the same quote only, that we have to enclose the entire string. Not only a word, the entire string, multiple lines, okay, multiple line string literals also, that we can take by using this double quote or single quote. So let us start working here. See, if I try to take without the quote Srinivas, you'll get an error. Why? Because it is not considering this Srinivas as a string. So that it is mandatory that we have to take Srinivas either in the single quote or double quote. Observe this, A equals to. First, let us check it whether it is comes under mutable or immutable. So here we not observed about the complex, right? So let us start working with the complex. A equals to Srinivas, right? I am taking A is 2 plus 3j. So it is 2 plus 3j. It is belongs to the complex. So check the ID. This is having some address. A equals to 10 plus 20j. Check the address of this A. It is different. Means complex is also immutable data type. Let us check the. So if I print, it will return Srinivas. If I check the type, it returns it is belongs to string. It is a string. Check the ID. So it is having some ID. So now I'm taking Python. So let us print this. Now it is written the Python. If you check the type, it is a string only. If you check the ID, it is having a different ID. So what is the meaning of this means? What is the meaning of this means? All five fundamental data types are belongs to immutable data types, right? So integer, float, boolean, complex, string. All these five fundamental data types are immutable data types in the Python. So let us observe with some more examples on the string. So now A equals to, Python is a programming language. Yes, no problem. Why? Because the entire string that I enclosed with the double quote. But my requirement is this programming I want to highlight. So in that process, I want to keep this programming in the double quote. So generally that we will, okay, take the words or something which you want to highlight in the double quote or single quote, right? So like that I want to take it. So for reusing these commands that what we type, that you can use up arrow and down arrow like this, and then we can edit that line. So now Python is a programming language. This programming that I want to highlight by representing with the double quotes. So let us observe here like this. So already that we observe that string is a sequence of character enclosed with a single quote or double quote. But here I'm starting the double quote here where I am ending. Python will not understand that, okay, with these multiple quotes, with these multiple same double quotes. It is a invalid format. So whenever if you want to highlight the words with a single quote or double quote, at that situation that we have to take the entire string in opposite quote. See, I want to highlight a word with double quote. Let us take the entire string in the single quote. In the single quote. At the time, it will accept, not a problem. Let us print this. Python is a programming language. Programming is in double quote. Same programming that I want to take in the single quote. At the time, let us take the entire string in double quote and then highlight that word in a single quote. Means opposite quotes that we have to take whenever if you want to add some extra code. Okay, if you want to add, okay, if you want to do some highlights in the string. So let us print this A. So like this that we can take. Now my requirement here it is, I want to highlight the two words. One is programming. Second one it is also that I want to highlight. Is in double quote, programming in single quote. Again, this double quote will not accept. Single quote is not accept on the entire string. Why? Because if you take double quote, multiple double quotes are there, more than two. If you take a single quote, then more than two single quotes that you can find in the program. So in these situations, for this type of requirement, we should go for the triple single quote or triple double quote. Triple single quote or triple double quote. Actually, this triple single quote or triple double quote is used to represent the multiple line strings. If you try to take a single quote or double quote for multiple line string, it will not accept. So at that time, we are going to use the triple single quote or triple double quote, the same triple single quote or triple double quote that we are going to use for these types of requirements also. So let us check here. So it will not come. Okay. So this type of, if I print this, let us check it. So here it is not returning these multiple quotes and something. So it is taking some 0. So now if I want to take this, consider this, means let us take this entire string in triple single quote or triple double quote. So let us print this. Now it will consider this double quote and single quote in a sentence. Actually, this triple single quote and double, okay, triple single quote and double triple quote, mainly we are going to use for multiple line strings, right? So in these situations also that we can use this triple single quote or triple double quote. See, like let us observe by using a single quote, I'm trying to write the multiple lines of string. I'm entering to next line, so it is raising an error. Why? Because single quote will not accept the multiple to move for the next line. Even double quote is also not accept, okay, to move for the next line. So in that line itself that we have to close it. So at that situation, we are having a triple single quote or triple double quote. By using triple single quote, I'm writing Python is, I'm moving for the next line. So these 3 dots indicates that, okay, that we are in the next line. Don't think that again, okay, we have to start the string or code or something. These 3 angular brackets represents that to start the code. So 3 dots indicates that we are in the same code in the next line. Python is a programming next line language and end with triple quote. So let us print it. Here it returns entire paragraph. Mainly for the purpose of paragraphs, that is multiple lines, we'll use this triple single quote or triple double quote. Like this, that we have to work with these standard data types in the Python. First 5 fundamental data types in Python. So let us observe some of the examples here. Some of the examples. A equals to 10. So whenever if you assign the 10 to the variable A is holding some address of this value 10. If I try to take a 20, so it will create in the new address. It is not update on the existing address. Let us observe here. If I take B equals to 10, B equals to 10. At the time of assigning the value to the variable, it contains some address. Already that we observe that our main intention is not to create the variables here. Our main intention is to store the value in the system. So in this process that we are assigning the value to the variable, so it required some space to store that address is holding by the variable A. Now, I'm trying to take that B equals to 10. Now this B is also having some ID, right? B is also having some ID. My question here it is, these two IDs are same or different? These two IDs are same or different? Yes, open the chart and then respond. If I check the ID of this A and if I check the ID of this B, now these two IDs are same or different? A equals to 10. So already 10 is stored in the system. Already 10 is stored in the system. So it contains some ID, right? So it contains some ID. Now, B equals to 10. 10. Already 10 is there in the system. Our intention is not to create a variables. Our main intention is to store the value in the system. Already 10 is there in the system. Now this B is going, okay, holds the same ID. Already it is there. 10 is already there, right? No need to create one more address for storing the 10. Already 10 is there in the system. They're not creating a new value. So now this B is going to take the reference of the ID A. B is holding the address of A only. Why? Because already A is there. Our intention is to create the values here, to store the values, not okay, to create the variables. So let us observe with examples. We'll get more clarity. A equals to 100. So if you print it returns 100. If you check the type, it returns it is the integer. Now ID I'm checking. B equals to 100. So here, whenever I'm taking A is 100 and B is 100, A and B are holding the same address. Now I'm going to take some more values. Let us observe this example. I'm taking A equals to 256 and ID, some ID. B equals to 256. Now let us respond in the chart. It is having the same ID or different ID. You have to check the B, right? Now it is having the same ID or different ID. Yes, same ID. A equal to 257 ID. B equals to 257. Check the ID of this B. Now it is having a different ID. See, 2432140H. Why? Because integer will accept the values from 0 to 256. That is total 257 value up to 256. It will accept in the same address only. More than that, it will take the different. Why? Because in a single execution, it is going to store the value. But if you assign multiple values, let us observe here. A equals to B equals to C equals to 100. So here, ID of this A, ID of this B, ID of this C is same. Why? Because in a single execution, 100 is assigning to the variable A, B, C. Now, A equals to, let us take x equals to y equals to z equals to 500. So here the id of this x, id of this y, id of this z, okay, it is same. Why? Because in a single execution, this 500 is assigning to the variable x, y, z. In this single execution, it will assign the single address. But the same 500, if you take in a different executions like x equals to 500 one time, y equals to 500, z equals to 500, in these three executions, it will, okay, not accept the same address more than 256. So this is the point that we have to note at the time of working with the integer data. At the time of working with the integer data. So it is okay, having some limitation, but other values, like for example, so all these things that you have to do the practice from your side. A equals to 10.5 id, so it is a float value, right? B equals to 10.5, check the id, same only. So it will also up to 256. All these things that you have to do the practice from your side. A equals to 256.5 id, b equals to 256.5 id of b. It is having different here. It is having the different address. Why? Because we are crossing 256, right? So a equals to 250.525, b equals to 255.25 id of this b. So here also 255 is also not accepting. So it is having some limitations. Okay, these limitations that you have to check by you, okay, with the practicals only. But it is not required to know the limitations on all this. But some of the technically, okay, written tests are somewhere that you can observe these type of technical, that's a logical questions. Like, let us work on different. The one point it is, okay, while working with the integer, okay, it will in multiple assignments also up to this range, it will assign the single address. Let us work with a different string, boolean and all. So we'll observe the whether it is going to accept or not.